Hello and welcome back to the Google APIs for Rust and YouTube Uploader development stream. Byron speaking, and it's still issue 45, Developer ACI Interface Grammar. Right now we are doing, because that is already done, we are doing the documentation. Oh, and silly me, I didn't even commit this yet because I was busy watching my own videos just to learn from my mistakes, of course. And because I kind of like it sometimes. Anyway, yeah, we have, it's actually docs for the CLI add required scalar arguments. That's really it. Nothing more to say here, I think. And let's go ahead and document the arguments that come next. So, for instance, here in watermark set, we have the channel ID and we have a request structure. And this is something we have to document next. And that is a bit more involved because we actually have to say, or basically show all the values that are possible, And this is basically the cursor parts here. Look at that. So we can have we can identify nested values using columns right now. Maybe we want to use dots instead. I was just thinking that kind of is more natural, I think, to most. So let's use dots. Let's do this right away. And and besides that, we want to basically traverse the hierarchy and document all the individual parameters here deeply. Must be deep. That's a requirement. And right now we don't have any of this. And let's see how far we get here. Okay, so first of all, I think I want to be sure that this separator, we might change our minds here. But, oh, that's the wrong one. Let's call it field sep, which is a dot now. Then I can right away change this colon here. Where is it? Param struct. Here it is. To field sep. Field sep. And the same here. Field sep. Awesome. So how do I call it? First, we have to hide it behind a condition. If MC request value, we have one of these, and if have request value, then we can have a headline that shall be called required request structure or required request value. Yeah, I think I should write something about it, right? Just to tell people what it is. So the request value is a structure. The request value is a data structure. Is a data structure with various fields. Each field may be a simple scalar, or I think the type of the thing I want to print as well. And I wonder, I also wonder how I'm supposed to set thing. I mean, this is actually the kind of difficult part here, and I might skip it for now. I might skip it over and just do the optional parameters ones because they are not nested. However, what I'm trying to get at is that we might have to set, or we might be able to set even to allow setting even nested vectors and stuff, and I don't know how to do that on the command line. I have no syntax for this in my head just yet. We just imagine the GeoJSON geometry type, which has a triply nested vector of float 64. So how do you specify this, without going crazy? It's difficult, I think. Yeah, I don't know. Maybe we can't set it, Maybe this is unsettable and that's it. But we have to determine if it's settable or not and then exclude it right away. And that's the point here. And we have to be smart about this. And I don't want to duplicate code to get there as well. But yeah, we have to see. Okay, each field may be a simple scalar or a structure or another data structure. Data structure. In the latter case, it is advised to set the cursor set the field cursor to the given data, to the desired data structure field, to the data structures field, to more easily specify values, something, to specify values more concisely. Oh, I should probably turn on the spelling correction here. More concisely. For example, I don't want to write too much here because kind of the preamble that is always written, but I also want the documentation to be complete and understandable or useful. So I guess we have to find a good middle ground here. We have to find our middle ground. For example, a structure like this. And now we want to have, how do I think like that? I can specify the structure. Let's just use JSON here. Let's use JSON. So we have a scalar field, which is, how does JSON even look like? Ooh. Show me. Real quick. Show me. That is not JSON. What the heck? Not a single JSON example. You want to mess with me? Here we go. Okay, that's the complete reference. The internet hates me. I just want one example. Maybe I should have searched for JSON example. Come on, just give me an overview here. Like, one thing. That's what I want. Thank you. So it's Cullen. That's what I was interested in. Good. Cullen. And that's all, huh? Scalar shall be, that's scalar int is 5 and scalar string is foo. And then we have the substructure, another struct, which is this, and then we have, well, I don't know, does it support bools? Let's use scalar float, which is 2.5 or something. Doesn't really matter, just the structure, right? But I have to start with something. Okay, so let's just do it like this. And there's also kind of, let's put it like this so that it shows that you can also reset the cursor to be nothing, right? It's also valid. Yeah, something like that. And maybe even another nesting level, just to show off. And another struct, which shows that basically we are always relative to the root. That's how we deal with that. And here we have a scalar. Yeah, do we allow vectors? I think lists lists are allowed as long as they're not nested or anything. Because basically what we need names for the types, you know, and the scalar is fine as long as it's just a single one and not nested. Hash maps we support as well. We should support hash maps. And I don't know yet how to do that, but I think I should include it in the example. So here we have all the complexity. So once again, it's foo, it's buzz bar. And we have, I think it's not really scalar anymore if it's multiple ones, so it's strings. And a mapping. Yeah, the thing is, this is kind of this is our internal type, right? So the mapping that I have here, it's how do we do it? If you have a mapping that is kind of a hash map, how do I specify this even? That's kind of weird. Anyway, let's see how that looks like. In Markdown, if it works at all. It does work. Here we go. So that is the one thing. Now we go back to video insert, I think. Videos, insert, index. Doesn't look too bad. I don't know why it does it as it does it, like individual lines. I don't know. Is it possible to say something like this? And this to have it look like a consecutive thing? No, unless maybe now it doesn't want the extra spacing anymore. Let's see, I have no idea. It's Markdown stuff after all. Nope. The good thing is that kind of works, huh? So we don't need the extra indentation level. Yeah. Do I need this to make my point? I don't think so. Let's keep it really, really easy. Okay. And if I say JSON, does it do anything? Not really. But it's interesting that this even works. Good. Yeah, but it's weird. Scalar int, you know, it kind of has a weird indentation to it. Let's have a look. Make docs. There must be some documentation about it. Styling your docs. Oh, that's not it. Writing your docs. There should be some info about code. Fence code blocks. Okay, this is why that works. With a line containing 3 or more backticks characters and ends with a line. Okay, good. So that's what we're doing. But it doesn't look good. Maybe it's the scheme or the theme that we have been using here. I like this sidebar, but I don't like the rest. Okay, anyway, so here now we document this. I think then we are done with that and just move on, because that is kind of the major undertaking here that will permeate through everything we do, so we better do it right, because we don't only have to accept this as input, we have to parse it later. And yeah, that's basically it. And fill in our actual structures, right? And yeah, it must be also come possibly in the right order. Yeah. And it's not super trivial if you ask me, because we have all these optional values all the time, and yeah. Anyway, it's doable definitely, but it's also not super trivial. We have to be careful. So, for example, a structure like this can be set completely with the following arguments. Note how the cursor position is adjusted to the respective fields. Okay, so here we go. So how would that be looking like? We have -r. I think I want to get this here. So either the equal form or not the equal form supports. Yeah, so it's -r. Then we can set the first scalar int, which shall be 2. And then we do -r. Now we set it. We should set the cursor to struct. And now we can set scalar float. And the scalar float only occurs in the nested struct, so it's kind of clear what we mean. And then we can set the cursor to the new struct, which is struct dot. So we should use that one here. The separator, field sep, struct field sep struct. So it always starts from the top. We don't support. Yeah, I don't know if we actually want to support relative things or not. I think supporting relative cursor thingies will be easier, but we don't know if it's relative or not unless we have an initial field separator here at the beginning. And we also must be able to reset it somehow. So let's explore this. Right now I just struct, let's call it substruct, just to be explicit. Substruct. And now we can do the substruct stuff. And it's -r strings, and this will be appended. Strings first R strings. Actually, we don't need to do that. That's the shell after all. Second. And now -r mapping is, how do we specify mappings? So that's key equals, it's like a double equal thing. You know, that's fine. It's just us who has to parse it. DocOps is out of the game for that. And I think we can easily parse this. Key equals value. And we will do the type conversions accordingly. And now we set the thing again. How do we get back to the top? I think just with this field separator. Huh? The thing is, it looks like what we want is, it's relative. It's always relative. Unless we start with a dot, then it's absolute. I think that's the thing. So here, the dot is the field sep, which basically sets it back to the top. And now I can just keep going and say scalar string shall be new one something. Shall be other. All right. Now we can basically say a few things about the special cases. The cursor position is always set relative to the current one, unless the field name starts with a dot. Starts with the field sep character. You can specify nested Fields can be nested. Can be nested, such as in -r, and then we have f field sep s field sep o or something. Field, subfield, other field, who knows? Like this. Vectors. Lists are always appended to each invocation of a field that is a list, are always appended to. In the example, the list will be the list at, and I shall just use a field name here, which also can be set to set values right away, right? We always resolve fields based on the current cursor, I think. So anyway, the list at struct field sep sub struct field sep strings will have the value. Let's just do it like this. What do we add there? First, second. Yeah. Yeah, let's specify this as well. Now the mapping. Mappings are set using using the key equals value form. Equals value form, and of course you can set as many of these as you want. Last but not least, maybe we want to have a list here, huh? The cursor position. Let's do it like this. Mappings, fine. And now the last thing. You may have, you can use fully qualified field names based on the current cursor. You can also set nested fields without setting the cursor explicitly, such as, to set the mapping, or to set the mapping right away. For example, to set the mapping right away from the root, you would specify -r. And then we have, this is always relative to the cursor, so no absolute thing going on, even though this would be supported, obviously. It's like a temporary cursor, right? We dive down and we'll discard the cursor position afterwards. So, and that's the difficult part, I think. Getting the code right to be able to do that, because it's going to be in a massive match struct. We might want to have functions for all of this, I guess. Anyway, a solution slowly forms in my head, but slowly. I at least feel I can do it. That's good. That's a start, at least. So we start at struct field sep sub struct field sep, then strings equals. Oh no, we wanted to have the mapping, right? Mapping equals foo equals bar, and that's how we dive down and set the value right away. In case the cursor is not at the root, you may explicitly drill down from the root using a leading which is kind of, it's just logical that this works. A leading field step character. Like that. All right, so that's basically just, we write down what we want to understand what we want, because later this has to be implemented. And also for the documentation, this needs to be made available somehow. And I think that's really the preamble to how this works, because people have to understand, I guess. And we will repeat this over and over, even though we might at some point, I think what I would prefer is if this example here would be made based on the actual data structure that we have, so that you can see the data structure as JSON here. Yeah, it's actually something I would find highly valuable, because then we make the examples. I think that's what I want. Awesome. That's what I want. First, list the data structure, and then we basically show how all this would work using the cursor. And this is kind of some general documentation that we might add then. And it's going to be a long list of things, I guess. Yeah, something like that. But that seems feasible. Let's see, 27 minutes. I think it's a good time to say we move on and do the simple things first, so to have it completed here, right? And the rest will be. I think the rest I will put into a separate ticket, because I want to finish this one that we are on right now, because it has seen enough work already. Thanks for watching, and have a good day.